Welcome everyone. That is Harry Potter there in the middle, I believe. I've never read any of the books, but I hear they're good books, so maybe you could check out Harry Potter. Today we're going to be doing Chapter 5, Section 5, Write Indirect Proofs. And I know you're all freaking out because you see the word proof, but this is not bad. It'll be a quick lesson. Alright, indirect proofs are, there's Harry Potter again on this slideshow. An indirect proof is used in a problem where a direct proof would be difficult to apply. It is used to contradict the given fact or theorem or definition. So here are the steps for writing an indirect proof. First, identify the conjecture to be proven. Second, assume the opposite or the negation of the conclusion is true. So that's kind of the key part. Number 3, use direct reasoning to show that the assumption leads to a contradiction. And 4, conclude that since the assumption is false, then the original conjecture must be true. So again, basically, if you're indirectly proving something, you're going to assume that it's false, assume the conclusion is false, so then you could show a contradiction, therefore it must be true. Alright, so here we have write an indirect proof that a triangle cannot have two right angles. Well, let's think. Can a triangle have two right angles? Well, no, it can't. So again, if you need to think about that more, go ahead, but I know right away it can't. So let's prove this indirectly, and we're going to basically assume that this is false. So we're going to assume a triangle can have two right angles. So again, just identify, okay, great, and again, assume the opposite of the conclusion. So we're going to assume an angle has two right angles. We're saying it can have two right angles. And hopefully we can show a contradiction. That's our goal. Alright, so use direct reasoning to lead to a contradiction, like I said. Well, our three angle measurements, 90, 90, 90, sorry, two 90s. That's a 180. What does that leave for your last angle? Measure of angle 3. 0 degrees? What? That cannot be true. So by the protractor postulate, blah, 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 a triangle cannot have an angle with a measure of 0 degrees. That's impossible. So let me ask, did we prove this proof? Yes, we did it indirectly. So that's what an indirect proof looks like. Now we know, we can conclude that the original conjecture is true, that they cannot have two right angles. So right here, cannot have two right angles. Alright, last one for the day. Again, this is a quick lesson. Let's try and break this under 4 minutes. Let's go. Alright, angle H is not congruent with angle K. So that's given, and we want to prove JH is not congruent with JK. Well, first we're going to have to assume JH is congruent to JK. So again, we have to assume the conclusion is false. So then, well, if JH and JK were congruent, wouldn't it be an isosceles triangle? And if it's an isosceles triangle, doesn't that mean the angles opposite to them are congruent? See, then H is congruent with K. That's by the isosceles triangle theorem. And then, since H isn't congruent to K, isn't that in the given? Yeah, so that's a contradiction. Then JH is not congruent to JK. And we're almost at 4 minutes. See you guys. Gotta go. 3:59.